Hey guys, welcome back to Algebra 1. Last time we introduced you to polynomial equations and factoring using the greatest common factor. So we're not going to be solving polynomial equations today because well, I expect this video to be pretty long. I'm going to be covering like 3 different lessons for factoring today. Okay, so I strongly suggest that you try to take this video into parts, come back to it later, okay? But we're going to get started here. So, as we might have told you before, factoring is really the opposite of multiplication. Opposite of multiplication. You know how you multiply 2 binomials together and you get trinomial as a result? Well, we're turning those trinomials into 2 binomials being multiplied together. That's what we're doing here today. So we're not using greatest common factor not very much today, but we're going to be examining factors instead. And so that's why I brought my buddy, Chrome Canvas, here to help us out today with factors. Say, hi, Canvas. Alright, too much fun. Alright, so let's get started. So we're going to start off by factoring quadratics, where the leading coefficient is 1. Okay, so let's try it out. Try it out. These are going to be your fundamental trinomials you're going to be factoring here. Okay, so let's try it out. So here's your first one: x squared plus 10x plus 16. As you can see, there is no greatest common factor. So what can we do? Well, for this situation, we take the factors of 16 and see which of these, which pair of factors adds up to 10. So, factors of 16. There's 1 and 16, 2 and 8, 4 and 4. Okay, so once again, we're looking for the factors that add up to 10. The answer is 2 and 8. All right, so the way we can do this, all right, so we take those factors right here, and then just plug them in. We put x plus 2 over here, and x plus 8 over here. Over here. Note that they are both positive because this sign that's right next to the b value is positive. Okay? Alright, so, and note that because this is positive, we're working with the same signs here. So that's what we're working with. Okay? Why don't you try this one out? It's going to be the same thing, use the same process to factor this trinomial. Okay, let's try it out. So I'm going to clear this out and list my factors of 6. Alright, so we list the factors of 6. We have 1 and 6, 2 and 3. There's a plus value in the middle, so the plus value in the middle, so the factors must add up to 7, because that's our b value. And then, since we have a plus sign right next to 6, the signs must be the same. It must be the same. So let's try it out. So we're looking for the pair of factors that adds up to 7. It'll be this one right here. 1 and 6. And so this is the way we factor this trinomial. Now, you can check your work by multiplying these binomials together and see if you can get the same result as this. And if your answer is correct, then you'll know that you factored it right. Alright, now I'm going to let you try this one. Now note the difference between this one and this one. Note that we still have a plus value, so the signs in our factors must be the same. However, we got a negative value instead of a positive value right next to b. So the factors must be negative. The constants and the factors must be negative. All right. So we are still looking for factors that add up to, looks like it's going to be 8, using the factors of 12. But the thing is, they have to be negative. So we're going to put in 12. And your factors are 1 and 12, 2 and 6, 3 and 4. When we're looking for the factors that add up to 8, it's going to be 2 and 6. Note that they are going to be negative this time, as so. All right. This one should be pretty easy because 3 has only got 2 factors, but I still want you to try to factor this out on your own. Okay. All right. Let's see what you got. So we have w squared minus 4w plus 3. So we have a positive sign right next to 3, so the signs must be the same. We have a negative sign right next to the 4, so the signs must be negative. Okay. So the only factors are 1 and 3. Luckily, the only factors of 3 are 1 and 3. Luckily, they add up to 4. So the way we factor this is w minus 3, w minus 1. And then if you were to, and then quick thing, if you were to set this equal to 0, you get w equals 3 and w equals 1. Just thought I'd throw that out there, since we're not really solving equations today. Alright, this one gets a little bit tricky. Alright, so we have x squared plus 4x minus 21. Alright, so note that this value right here is negative. Here is negative. Okay, so the signs must be different. And because we have different signs, we're not adding factors, but we are subtracting factors so we can get to 4. Okay, so we're going to list out our factors of 21. And the factors are 1, 21, 3, and 7. And that's it. So we're looking for the values that add up to that subtract to 4. Second minus first factor, by the way. So it's 7 minus 3, which equals 4. There's our answer. All right. So 7 and 4. So there is a specific arrangement you need to do. So first off, you need to take the bigger factor first. In this case, it would be 7. This sign is going to drop down right here. And then we need to have different signs for the other factor. And there you have it. There's our factoring. Pretty tricky stuff, but cool. All right, try this one. We have b squared minus v minus 42. So our c value is still negative. So you need to use the same process we used for the last problem. Okay? So pause the video and try to work this out on your own using the factors of 42. Okay, so let's try it out. So we're going to clear this out. 42 is our value we're looking at. So we must look for the values of the factors that subtract to, looks like it's going to be 1. So it's going to be 1 and 42. 2 and 21, 3 and 14, 6 and 7, and there it is, 6 and 7. Heaven, right there. So we look into the factors that subtract to 1. It's going to be 7. It's going to be 6 minus 7. Like 6 and 7, 7 minus 1. So we take again, the way we factor trinomials like these is that we take the larger value first, we take the larger factor first, drop the sign, and then write out the other factor in the opposite sign. Alright, and there's our factoring right there. There. Some teachers may ask you to do a guess and check sort of deal, but we're not doing that. I learned a more helpful factoring method in Algebra 2. And this is the one I'm showing you right now. Okay? So anyways, that's it for part 1. The next part is going to get pretty tricky, so I suggest cutting out for the video and then coming back to this later. Okay? So if you're leaving, take care of yourselves and have a good rest of your day. Those of you who are staying, hi there. Or just coming back, hi again. We are now in part 2 of factoring quadratics. So last part we took a look at quadratics in which the leading coefficient was 1. Now we're going to take a look at factoring quadratics where the leading coefficient is not 1. Alright, okay, so we're going to start off with a basic review of greatest common factor. Okay, so the way we're going to do it is take a look at every coefficient in a variable. There is no variable in every single term, so I think we're just going to have a coefficient here. Okay, so we're going to take, so it looks like 5 goes into 5 once, 5 goes into 5 twice, 5 goes into 15 thrice. And so we can take out that 5 right there and leave the rest in parentheses. I'd say we're not done yet, so we're just going to keep going. Factors of 1 and 2 are 1 and 2. They add up to 3, luckily. So we're just going to write this out. It's x plus 2, x plus 1. All right. Why don't you try this problem out right here? Here. See if you can factor this out. Use greatest common factor and then factor the trinomial that's left. Okay, so pause the video and work this out. Okay, so let's try this out. So we have ax squared minus 56x plus 48. A variable is not in every single term, so the greatest common factor does not have a variable. However, I can see that 8 goes into 8 once, 8 goes into 48 6 times, and 8 goes into 56. Oh, 8 goes into 48 6 times, and 8 goes into 56 7 times. Okay, so we're going to take that 8 out, and then put everything back in. 8 goes into 56 7 times, 8 goes into 48 6 times, and that's what's left. We got a C value that is positive, but a B value that is negative. So, same signs, but the factors are negative. So the factors of 6 are 1 and 6, 2 and 3. 6 and 1 look like they are the factors that add up to 7, and so there's the factors right there. All right. Now, alright, that's it for the easy stuff. I'm gonna be mean to you now. Here comes the hard stuff. Alright, so now we're looking at 4x squared plus 13x plus 3. Okay? So there is no greatest common factor, but don't worry, this is still factorable. It is gonna get a little ugly, so be prepared. Alright, so we're looking at the A and C values. C values, doesn't matter their sign. And then we're going to multiply those two together. It looks like, so it's going to be 4 times 3 equals 12. Alright? And multiplying A and C together it tells us what factors we need to look for. So we're going to look for the factors of 12. 1 and 12, 2 and 6, 3 and 4. And look, we need the factors that add up to 13 because we're still adding up to the b value. And b is positive. All right, so we're going to use 1 and 12. All right, so now we are ready to factor this out. So I'm actually going to put them stuff in parentheses, so it's going to be 4x squared plus 12x, then close parentheses, and it's going to be plus, darn it, here goes sticky keys again, x plus 3. Now note why I decided to do this. It is because I was able to group the terms so that they share the greatest common factor. Okay? So that's why I did it this way. And you don't need to see that. Alright. Now, we're going to try and factor this out. So it's going to be, so let's factor this term out. So it's going to be 4x times x plus 3. And then plus 1 times x plus 3. And then we just take x plus 3 right there, leave it as is, and then take the rest. See what I did there? That's how factoring works in these tough situations. All right. So now we're going to let you try this one. So it's 3x minus 7x plus 2. So use the same process that I used. So take a times c, find the factors of a times c, find what adds up to 7 because c value is positive, and then factor from there, just the way I did. Okay, so AC is 6. We are looking for the factors that add to 7. So it's going to be 1 and 6, 2 and 3. Looks like 1 and 6 add up to 7. Now, I'm going to group these terms together. It's going to be negative 6x because that b value is negative. And then plus negative x. I'm just going to use it with minus. Plus negative x plus 2. Alright, now just take the greatest common factor of each. And then it's going to be 3x, x minus 2, minus 1, x minus 2. So one thing you need to know is that these two must match. If you don't get a match, then chances are you got a polynomial that is not factorable. Okay? Let's say, okay, so we're going to take that match and then take the rest of the stuff in. Alright? Alright, so now we're going to try something else. So we have 2x squared minus 5x minus 7. So now notice that our c value is negative now. So we still need to multiply a and c together, and 2 times 7, doesn't matter the sign, we're just going to multiply them together. So it's 2 times 7, right? 14. And we are looking for the factors that subtract to 5. Subtract because c value is negative. Subtract 5, right? Yep. 1 and 14, 2 and 7, 2 and 7, subtract to 5. Alright, so I believe that the larger factor must be negative. I'd say it's so 7 must be negative. And so the way we do it is 2x squared plus 2x, I need to put this in parentheses, plus negative 7x minus 7. Note that 2x plus negative 7x is negative 5x. 5x. So yes, we need to take that, and take the greatest factor and drop that sign next to the b and put it over here. Okay? Now we factor. using GCF. So it's going to be 2x times x plus 1 minus 7 x plus 1. Take the match and leave it out right like this. There you have it. There is your factoring for that polynomial. Now I want you to try this one. We now have 4x squared minus 19x minus 5. Okay, so I want you to pause the video, work this out on your own. Use that process that I just showed you. Okay, so note that we took that our A and C value was 4 and C value was 5, so it's 4 times 5 is 20. We are looking for the factors that subtract to 19. Looks like it's going to be 1 and 20. I'm just going to say that right now. So we can rewrite this as 4x squared. Take biggest factor must be negative 20x plus x minus 5. Take greatest common factor of each. We get 4x times x minus 5 plus 1 times x minus 5. Take that match. Put in the rest. There you go. Alright, so now this one is going to get very tricky. Always pay attention to that leading coefficient. Notice that it is negative. So, what do you do here? Well, the way we do it is we actually have to take that negative out. So we negative out. All right, I'm just gonna clear these comments out. And so 4x squared, it's going to be plus 8x, and yes, we are multiplying every single one by negative 1. All right. Now I got a negative c value and a positive b value. So we're going to take 4 times 5 again. It's going to be 20. I guess I should have kept that. So those are your factors. Ooh, 10 and 2 subtract 8. So I'm going to take that. So it's going to be negative 4x, 4x squared plus minus 2x plus 10x minus 5. All right. And now we factor with the greatest common factor. All right, so it's going to be 2x minus 1 plus 2x plus 5, 2x minus 1. All right. And now we throw it out there. Throw it out there. So it's 2x negative 2x minus 1 times 2x plus 5. All right. Now try this one. So it's going to be negative 3. Oh, we need a break. Negative 3x minus x plus 2. All right. So now I want you to pause the video and try to work this out on your own. Remember to take that negative out before you start factoring. Okay, so we take the negative out and everything is reversed. So it's going to be positive 3x squared, positive x, negative 2. All right, now we take a times c. That's going to be 3 times 2 equals 6. We're looking for the factors that add to 1. So 1 and 6, 2 and 3. 2 and 3 add 3 and minus 2 is 1. Okay? And it's a negative minus because that c value is negative. Alright, now I group terms. So what are the factors we choose again? Yes, those ones. 3x squared plus 3, right? 3x plus negative 2x minus 2. Alright, now we take the greatest common factor out from each. So it's 3x, x plus 1, minus 2, x plus 1. And now, everything is ready. Everything is ready. Take the match, put it in the rest. And there you have it, folks. Alright, so that concludes part 2. So, if you're ready to go now, you may go. But next time we're going to be talking about special products, okay? It's going to be really brief. But if you'd like to go, check on later, go when you need. Those of you who stayed or are coming back, welcome back. So we are now ready to look at special products. So this won't take long, guys, don't worry. So we're going to be learning 2 different patterns today. The first one is difference of 2 squares. If you have a difference of 2 squares, you need to use the sum and difference pattern. Remember that pattern? So this is pretty much the reverse of that pattern. So, you know this right here? X squared minus 25. So, we can rewrite this as x squared minus 5 squared, and that will give us our a and b values for when we factor. Alright? And so this factors into, x plus 5 and x minus 5. Alright? Try this one out. 4z squared minus 1. So I want you to take a look at what it did, and then I want you to factor this binomial. Okay, so we can rewrite. Alright, so let's find our a and b values before we try and factor. So we can rewrite this as 2z squared minus 1 squared. And so our a value is 2z and our b value is 1. So we can write the factor form as 2z plus 1 and 2z minus 1. Alright? So that's the difference of squares. That's pretty easy, right? Now, well, this one. So there's 2 rules to factoring perfect square trinomials. So let's take a look here. So we have n squared plus 8n plus 16. Notice that the square root of the n squared is n, and the square root of 16 is 4. And so if we were to multiply 4 and 2 together, 4 and n together, we get 4n. However, and that needs to be doubled, so we get 8n. And so this is indeed a perfect square trinomial. And so we can rewrite this as n squared plus 2n 4 plus 4 squared. And so our a value is n and our b value is 4. And so our factored form is n plus 4 squared. Why don't you try it out with this one now? 9z squared plus 36z plus 36. Okay, so we are now ready to factor. So notice that the square root of 9z squared is 3z, and the square root of 36 is 6. So we can rewrite this as 3z squared plus 3z 6 6, alright, and then 6 squared. And then this simply factors into 3z plus 6 squared. Alright, now watch out for this, for trinomials like these. These have negative signs, so it's going to be a minus b squared. Okay, so now let's try it out. 4x squared minus 12x plus 9. Well, we can rewrite this as 2x squared minus 2x squared root of minus 3, and 3 squared. And so this factors into 2x minus 3 squared. Alright guys, last one. I've had this video going on for long enough now, so I'm going to get a rest after this. Okay, so d squared minus 10d plus 25. So I want you to pause the video and try to factor this perfect square trinomial. Alright, so here we go. So we can rewrite this as d squared minus 2d. This better be 5. Yes, it's 5. And so we get d minus 5 squared. Right? Okay, I know that was a lot today, guys, but factoring is crucial to succeeding, especially to succeeding in high school math, especially when you get to Algebra 2 and pre-calculus, calculus, and any math beyond that. Okay, so be sure to do lots of practice problems on these so that you're ready for what's coming. Okay. Anyways, thank you so much for watching today, guys, and hope you have an amazing rest of your day. Next time, we'll wrap up this factoring. Yes, we're still not done. You're going to be factoring forever. Anyways, I like to have jokes anyways. Okay? I like to play jokes. Anyways, and thanks so much for watching, guys. Have a great rest of your day. So long, folks.